Good morning. Good. We'll continue with the problems. The next problem is the position vector of the points A, B, C are minus 2i plus j minus k minus 4i plus 2j plus 2k and 6i minus 3j minus 13k respectively and one more condition is given, that is, and AB is equal to lambda times AC. Then find the value of lambda. That is the problem. Find the value of lambda. The lambda value kanukkoli. So first in the solution, A point is nothing but OA vector. OA vector and minus 2i plus j minus k. Now B point is nothing but OB vector. So OB vector is minus 4i plus 2j plus 2k. Next C point vector. OC vector is 6i minus 3. Okay, now we'll find AB vector. What is AB vector? OB minus OA. OB and minus 4i plus 2j plus 2k minus of minus 2i plus j minus k. So when you subtract, you will get minus 4 plus 2. So minus 2i and then plus 2 minus 1. So plus 1j plus 2k plus k plus 3k. So this is the vector AB. Next is AC vector. What is AC vector? OC minus OA. So subtract in the same way like this. OC minus OA. So I am directly writing it is 6 plus 2, 7, 8i. And then minus 3 minus 1, so minus j. And then minus 13 plus 1, so minus 12k. So just simplify like this, you will get AC. Now what is given to us? You are given that AB is equal to lambda times AC. AB is lambda times AC. Also what is AB? Minus 2i plus j plus 3k. So this is equal to lambda into AC. Substitute. So 8i minus AC is AC, this minus this, no, so it is minus 4j here. So minus 4j and then now we'll simplify this. Is 8 lambda I minus 4 lambda j minus 12 lambda k. Now since I, j, k are non-coplanar, you can equate the coefficients of like vectors. So this implies, here I'll write implies, since I, j, k are non-coplanar, since they are non-coplanar, you can equate the coefficients of like vectors. So minus 2 is equal to 8 lambda. You can take any one, or you can take 1 is equal to minus 4 lambda, or you can take minus 12. Here I should write lambda. So lambda k, this is lambda. So 3 is equal to minus 12 lambda. Any one is enough. So from all this you can see you will get lambda as equal to minus 1 by 4. From all the three equations you will get lambda as minus 1 by 4. So this is your answer. So like this we do this problem. Okay. Now next problem. The second problem I'll write. So if OA is equal to I plus j plus k, and then AB is equal to 3I minus 2J plus K. So this problem is very, very important. And then BC is equal to I plus 2J minus 2K. And then CD is equal to 2I plus J plus 3K. Then find the value of the vector OD. Find the vector OD. Now, if you observe the given vectors, you can see that you are given OA. OA continuation AB. AB continuation BC. BC then CD like that. So, when you draw the figure, it is like this. AB. And then you have OA. So first you are given OA. So, suppose that I am taking this as O. So, OA. Next AB. Next BC. Next you are given CD like this. So this is like continuation OA, AB, BC, CD. So now what is OD? OD if I join, it is nothing but OA plus AB plus BC plus CD like that. So therefore we'll write the solution. You write. So therefore OD is equal to OA plus AB plus BC plus CD. So I can just add all the vectors and write the answer. That's all. It is very important for 2 marks. Even this problem is very important for 2 marks. So when you add, what is it? Add all the items. 1, 3 plus 1, 4, 5, 6, 7. So it is 7I. And then 1 minus 2 plus 2. So 2J. And then again 1, 2 minus 2, then 3. So plus 3K. So this is your, so OD is nothing but OA plus AB plus BC plus CD. Yes, next problem. Next A, B, C, even this is very important. A, B, C, D, E is a pentagon. If the sum of the vectors AB, AE, BC, DC, ED and AC is lambda into AC, then find the value of lambda. This is the problem. So what is given? ABCD is a pentagon. Okay, then what is given? You are given that the sum of all the vectors. So add them. AB plus AE plus BC plus DC plus and then ED plus AC. So this is equal to lambda times AC. So now what you should do is you simplify all this and write this also in terms of AC. So ఇదంతా కూడా AC లో రాసేస్తే lambda value వచ్చేస్తుంది ఈక్వేషన్. సో AC లో ఎలా రాసుకోవాలి? AB కంటిన్యూషన్ ఇక్కడ ఉంది BC. So you group these two terms. So AB plus BC. Then again if you see AE, you should start with AC. You should get AC. So AE continuation is here AD. So I'll write AE plus ED and ED continuation is here plus DC. So group these three terms. Now again one extra AC is there, that you write as it is. So this is equal to lambda AC. So now if you see AB plus BC is AC and then AE plus ED plus DC is also again AC. And then this is AC is equal to lambda AC. So you will get 3 times AC is equal to, so lambda is equal to 3. So like this we solve the problem. Like when you draw the pentagon A, B, C, D, E is a pentagon. So So AB plus BC, AB plus BC is AC. And again AE plus ED plus DC. AE plus ED plus DC is AC again. So like this we do the problem. Okay, next problem is the hexagon problem. Next one is hexagon problem. Even this is very important. So next fourth problem. Let A, B, C, D, E, F be a regular hexagon. Regular hexagon means all sides are equal. All sides are equal with center O. The center of the hexagon is O. Show that. The question is show that AB plus AC plus AD plus AE plus AF is equal to 3 times AD is equal to 6 times AO. That is the problem. So regular hexagon. It is a regular hexagon. So all sides are equal. So when you draw the figure, it looks like this. All sides are equal. A, B, C, D, E, F. Okay, now AB. This is given AB. Next AC. Next AD. Next AE. And AF. These are all given. So now what you do is AB, you should write in terms of AD. One AD is already there, so we'll not disturb this. Now AD is actually equal to AC plus CD, but CD is not given. We are given, instead of CD, we are given AB and then ED. AD is equal to AE plus ED. ED is not given. So we'll write ED as AB as ED. AB will write as ED. So we'll take left hand side. Left hand side. We must show this one. So we'll take left hand side. That is AB plus AC plus AD plus AE plus AF. Now we'll write AB as ED. AB is same as ED because they are equivalent. They are in the same direction. So AB is same as ED because AB is equal to ED. We are writing AB as ED. Next AC. AC will write as it is AC. Next AD. AD also will write as it is because we should get AD. Next AE. AE also will write as it is because we can group AE and ED. AE and ED is AE plus ED is AD. One AD will get. Next AF. AF is nothing but CD. AF is nothing but CD. So we'll write AF as CD because they are equal and they are in the same direction. Their length is same. AF is equal to CD. Now you group the terms like this. AE plus ED is AD. So you write AE and then ED together. So only the first one and the last one we are changing. We are writing AB as ED and at the same time AF as CD. Only these two you change. Now group the terms like this. AE plus ED is AD. This AD will write as it is. And then plus AC plus CD becomes AD. So group these two terms. AC plus CD because its continuation is here. So now if you see, this is one AD and this is another AD and another AD. So it is equal to 3 times AD. Hence it is proved. So it is equal to 3 times AD is equal to 3 times AD is equal to right hand side. We proved. Now you must show that 3AD is equal to 6AO. Now in the figure we know that is the center. O is the center. So this length. So AO is equal. So that means AD is equal to 2 times AO. AD is equal to 2 times AO, because you can write AD as AO plus OD. AO is same as OD. OD is same as AO. So we write AO plus AO. That is 2 times AO. Okay. So now therefore 3 times AD is equal to 3 into 2 times AO. That is 6 times AO. Hence it is proved. So we proved all the parts, all the things in the problem. Hence it is proved. Because it is a regular hexagon, so the O will be the midpoint of AD. A is the center. So we completed this problem. Now next problem. The next problem is again very important. Okay. This problem is very important. In triangle ABC, what is the problem number? 4, 1, 5. Fifth problem. So this is fifth problem. In triangle ABC, if O is the circumcenter, O is the circumcenter, and H is the orthocenter, and H is the orthocenter, then show that first bit, OA plus OB plus OC is equal to OH, and then second bit is HA plus HB plus HC is equal to 2 times HO. This is the problem. 2 times HO. Now what is circumcenter? Circumcenter is the point of intersection of the perpendicular bisectors of the sides. Perpendicular bisectors of the sides. Orthocenter is the orthocenter is the point of intersection of altitudes. Point of intersection of altitudes. So this is orthocenter. Orthocenter is our H, and O is the circumcenter. So what is circumcenter? Circumcenter is the point of intersection of perpendicular bisectors. Perpendicular bisectors of the sides of the triangle. So these are H and O. Now we'll take the first bit. First bit we'll take. We'll draw the figure. This figure you draw clearly like this. A. Then we'll draw only one altitude. ABC is the triangle. So orthocenter is the point of intersection of altitude. This is one altitude. So definitely the H will be somewhere on this altitude also. So when you draw another altitude, so on, they intersect here. So we'll take H on this altitude. Let AD be the altitude. Next O, we'll take one perpendicular bisector, midpoint. This is the midpoint. So we'll take one perpendicular bisector. So this circumcenter will lie on this. So we'll take this as O. And then we'll take this as some M. Now, this is perpendicular bisector. So that means this length is same as, this is the bisector. So this length is same as this length. These two are equal length. This length is same as this length, because this is M is the midpoint. So now when you take the vectors MC and then MB, they are equal but they are in the opposite direction. So MC is equal to minus MB because they are in the opposite direction. MC is in this direction, MB is in this direction. They have same length, but they are in the opposite direction. So we'll write it as the negative of the vector. OA plus OB plus OC. So we'll write OB and then OC in terms of OM, MB like that. Now we'll take the left hand side. Left hand side is OA plus OB plus OC. Okay, so it is OA plus OB will write as OM plus MB according to the triangle law. So it is OM plus MB. OM plus MB. And then OC is OM plus MC. OM plus MC. So you are getting OA plus 2 times OM plus MB plus MC. But what is MC? MC is minus MB. So we'll write MC as minus MB. So that will get cancelled. So 2 OM plus MB minus MB. So these two will get cancelled and we will get OA plus 2 times OM. Now we have one property from triangles that 2 times OM. 2 times OM is nothing but AH. We have 2 times OM as AH. This is from properties of triangles. In geometry you must have learned. So this is OA plus 2 times OM will write as OA plus AH from geometry. So you just write because of this condition. Now OA AH is in continuation. So OA plus AH is nothing but OH. So which is the right hand side. So we proved that the left hand side is equal to the right hand side. So this problem is very, very important. This is the proof. Now we'll prove the second one. HA plus HB plus HC is equal to. Okay. So for this we'll again draw the figure. So this is for first bit. Now we'll do the second one. So we'll again draw the figure. HA. So we'll draw the figure. Okay, A, B, C. And then we'll draw this is H. And then we'll draw this perpendicular bisector. So on this you have O. Now what is that you have to prove? HA. We'll take left hand side as HA plus HB plus HC. So HA plus, again we need this, MC is equal to minus MB. So we'll take this as D and this as M. So we need this condition again, MC is equal to minus MB. We need MC is equal to minus MB condition again. Now what is HB? HB will write as HM plus MB. We'll take this triangle. So HB is nothing but HM plus HB is HM plus MB from triangle law. And again HC if you write, HC is equal to HM plus MC. HM plus MC. Now this is HA plus 2 times HM plus MB. And then MC will write as minus MB. MC is minus MB because of this. So now the MB will get cancelled and you will have HA plus 2 times HM. But we have OM like that. So HM, what is HM? HM is HA plus AM. HM is equal to, what is the right hand side? HO. HM will write as HO, will not take this. HM is equal to HO plus OM. HM is HO plus OM. From again triangle law. HO plus OM. So this is HA plus 2 times HO plus 2 times OM. What is 2 times OM? Because 2 times OM is equal to AH. We'll write here HA plus 2 times HO plus AH. AH I can write as minus HA. When I interchange the initial and terminal point, it changes the sign. So change this 2 times HO as it is, and this is also HA as it is. So HA and HA will get cancelled, and it is equal to 2 times HO, which is the right hand side. Hence it is proved. Hence it is proved. So like this, we do this problem. Next problem. 66th problem. In triangle ABC, if B, C are the position vectors of the vertices, capital ABC respectively, then prove that the position vector of the centroid. Prove that the position vector of the centroid is 1 by 3 into A plus B plus C. This is very simple. We'll take the triangle ABC. We know that the centroid divides the median. What is centroid? Centroid is the point of intersection of the medians. Centroid of intersection is median midpoint. You take one midpoint and then you join the opposite vertex with the center of the base like this. So this is the median. So again, if you take the midpoint here and then you will join the opposite vertex. So this is another median, and then again midpoint here and then join. So this is the median. So point of intersection of medians. Centroid is the point of intersection of medians. Now we know that the centroid divides the median in the ratio 2:1. Centroid divides the median in the ratio 2:1. So what we'll do is we'll take the position vector of the midpoint of one side. Any one median is enough for us. We need not take median. So we are given that A is equal to OA is equal to A bar, and then B is equal to OB is equal to B bar, and then C is equal to C bar are the vertices of triangle ABC, are the position vectors of the triangle ABC. Point will take D. Suppose that D is the midpoint, equal to midpoint of D can write as OD. So midpoint we are given by the formula B plus D by 2, B plus C by 2. This is the midpoint. Now the centroid, suppose that the centroid is G. So the centroid G divides the median, centroid D divides the median AD. Any median you can take, so we'll take the median AD in the ratio. It divides the median in 1 into A. 1 into A by 2 plus 1, that is 3. So it is equal to A plus B plus C by 3. So therefore the position vector of the centroid. So the position vector of the centroid is equal to A plus B plus C by 3. Position vector of centroid is nothing but OG. We'll continue in the next period.
మేము ఇంట్లో గుడ్లు పెట్టకుండా మమ్మల్ని ఎవరు ఆపలేరు. నేను ఆపగలను. నీకు తెలీదా మేము ఏడీస్ దోమలమని? మేము డెంగ్యూ చికెన్ గుని అని వ్యాపింపజేస్తాం. మాస్టర్ గారు స్కూల్లో డెంగ్యూ నుండి నివారణ కోసం అన్ని వివరాలు చెప్పారు. అవునా బాబు, మాకే ఛాలెంజా? గుడ్లు తప్పకుండా పెట్టి తీరుతాను. పెట్టనివ్వను. అయ్యో, ఇక్కడంతా శుభ్రంగా ఉంది.
డెంగ్యూ నుండి నివారణ కోసం